All right, friends, we're going to get started with the Unit 2, Section 4 notes. In this section, we're going to be talking about some properties that you may have seen before, may have heard of before, but they are really going to allow you to make sense of certain rules that you're following without probably even thinking about it. So the first two properties that we have here in this chart are the commutative property of multiplication and addition, as well as the associative property of multiplication and division. So the commutative property of addition says that when you're adding numbers, you can add them in any order. So 4 plus -7 equals -7 plus 4. So when you have two add-ins, you can reverse the order and it still gives you the same sum. Same thing with multiplication. When you're multiplying two numbers, right, the order doesn't matter. You feel free to switch these. So an example where you may have seen this has to do with area, right? So the formula for area equals length times width. You're going to get the same answer if you multiply the width times the length first. All right, so the associative property is similar, but that it says changing the grouping of the numbers in a sum doesn't change the sum. So if you have 9 plus 6 plus 2, 9 plus 6, then adding 2 equals 6 plus 2, then adding 9. And it's the exact same rule with multiplication and addition, excuse me. All right, so two more properties I'd like you to write down. One is the identity property of addition. And that property says that any number plus 0 equals itself. So 7 plus 0 equals 7. The next one I want you to write down is identity property of, you guessed it, multiplication. All right, so this says that any number times 1, whoops, let's get that eraser there, handy dandy eraser. All right, -9 times 1 equals -9. 2 times 1 equals 2. All right, so, and like I said, you probably have been applying these rules without really even realizing that they were called certain properties. All right, so if we look at our first example, 14 times 7 times x equals 14 times 7 times x. So you know it's going to be a multiplication property because we see that multiplication sign there. And because the grouping symbols have changed, this is the associative property of multiplication. The second one, we are adding 0 and our sum is not changing. So this is the identity property of addition. Number 3, we are multiplying -525 by 1. So that is the identity property of multiplication. Last but not least, when we look at number 4, -15 plus 12 also equals 12 plus -15. So that is the commutative property of addition. All right, friends, so now we're going to put these properties into action with numbers 1 and 2. So it says evaluate the expression using mental math. So your brain is already using these properties, whether you know it or not. And so, for example, 17 plus 32 is trickier for me to do in my head than it is if I do 17 plus 23 first, then add 32. So 17 plus 23 is an easy 40 plus 32, and then I can quickly tell you that it is 72. Same thing with number 2, right? 4 times 19, I can't do that math in my head very quickly, and I may make careless errors if I do that, but I can do 4 times -25 pretty confidently. So 4 times -25 times 19. We know this is -100 times 19, and then we have -1900. All right, moving right along to the back. Same thing here. Think about what decimals it makes sense, what order it makes sense to add these decimals in. I like to work with numbers that make 10. So I'm going to add 6.8 plus 2.2 plus 9.7 to get 9 plus 9.7, which is then simply just 18.7. Number 4, again, I think working with multiples of 5 is easy. So -4 times -5 times 9 equals 20 times 9, which then I know that equals 180. All right, friends, look what we have here, something that should look very familiar. We are going to evaluate expressions. So I hope you're not tired of doing this because we are just getting the party started. The first one says a squared times b times c squared. So we're just going to plug in our values like we've done before. A equals 10, so this is 10 squared times b, which is -4. And c equals -2 squared. So this is going to be 100 times -4. -2 squared is -2 times -2, which is 4. I then can do 100 times -16 to give me -1600. All right, moving right along to number 2. 3 times b would be 3 times -4 plus 5 times 10 plus -6 times -2. Working in order from left to right, this is -12 plus 50 plus 12. If you can already see that -12 plus 12 equals 0, you are one step ahead of the game. That is our next step. To get 0 plus 50 equals 50. All right, number 3, a squared b times 6. This is going to be 10 squared times b, which is -4, times 6. This is going to be 100 times -4 times 6. So this is 100 times -24, which equals -2400. All right. I'm going to leave number 4 for you to try. Make sure you check your answers with your teachers. The answer keys are in the classroom. And if you have any questions, please be sure and ask them. All right, friends, move into a new section. So we are going to use these properties to simplify expressions. So m plus 5 plus 9. We know that 5 plus 9 is 14. And then we need to add m to it. M and 14 are not like terms, meaning we cannot add those together. So that is our final answer, m plus 14. If we had 2m plus 3m, we would get 5m because we have that common m there. But 14 doesn't have an m, so this is our final answer. All right, number 2. It says 3k times 6. When you multiply, even if they do not have the same variable, right? Only if one has a variable, you can multiply them. So we couldn't add them, but we can multiply them. So this is going to be 3 times 6 times k, which is 18k. All right, I apologize that there isn't much room to write number 3 and 4, so feel free to write above it up here where it says name and date. If you need to pause this video and add a post-it, now would be a great time to do that. So 4 plus x plus -1, so this is going to be 4 plus negative 1 plus x. 4 plus negative 1 is 3 plus x. Those are not like terms, so we stop there. Negative 21 times 3t, we can multiply those together to get negative 63t. All right, the last section we're going to look at here today is multiplying by a conversion factor. So again, this is something you probably do automatically, or you may have done this in science even, but I'm going to show you how I would like you to write it. So if we think about 27 yards to feet, we know that there are 3 feet in a yard. So I'm going to start off by saying 27 yards over 1 times 3 feet over 1 yard. So this right here is my conversion factor. The numerator and denominator here need to be equal, right? You're probably wondering, well, how do I know what to write on the top and how do I know what to write on the bottom? Well, we know our final unit we want to be in feet. Therefore, if we have yards on top to start, if we put it on the bottom, it cancels. Therefore, now we're just left with 27 times 3, which equals 81 feet. All right, I realize that can be a bit tricky writing it that way if you've never seen it that way before, so please just ask your teacher if that is unfamiliar to you. All right, so 160 kilometers to meters. We have 160 kilometers or kilometers over 1 times, we want to get to meters. So I need to put kilometers down here, and I know that 1,000 meters equals a kilometer. So then my kilometers cancel. 160 times 1,000 is 160,000 meters. All right, friends, we are rolling right along here. Last one, I would like you to try on your own. But again, we are here to help you. So please don't feel like you can't ask us questions. We want to help you if you are stuck. All right, and then for the review problems, you have some order of operations practice. You have some coordinate plane practice in the second set. Remember that your coordinate plane is divided into 4 quadrants. Describing the location of the point, you are telling me what quadrant that point would be if you were to plot it. All right, so give this your best shot. I realized there were some problems in this section that could be a bit tricky, but be a risk taker, give it your best shot, and let us know how we can help you.